The broadcast is now starting. All attendees are in listen-only mode.
Good morning and thanks for joining our webinar today jointly with Skybox Security on reducing your attack surface and how you can best practices that you can learn to deal with recent threats and attack trends. My name is Shona Bradshaw. I'll be hosting the webinar today and I am delighted to be joined by two very senior presenters from Skybox, Michelle Cobb, who is the Vice President of Worldwide Marketing, and also Alistair Williams, who is the Technical Director for Europe, the Middle East and Asia. So I will just very quickly run through what we're going to cover today and then hand over to these people who are able to take you through the webinar content. So just to give you a very brief objective and agenda for this morning's session. Today's been designed to give customers insight into how they can respond to increased network risks and increased volume of breaches, essentially by taking a comprehensive approach to understanding and then minimising their attack surface. We'll start off with a very brief Bytes intro. Most of you are aware of who we are, so I will keep it brief. And then I'll hand over to Michelle, who will introduce Skybox, some of the recent attacks and what we need to learn from them. And lastly, then hand over to Alistair, who will take us through a demonstration on best practices to reduce your attack surface, critical factors in increasing network visibility, and a technical demonstration of Skybox before a live question and answer session. A little bit of housekeeping for this morning's session. Attendee lines are on mute throughout the webinar just to increase the audio capacity. However, questions are welcome. Please do post them via questions and chat throughout the webinar as they occur to you, and we will run a live Q&A at the end of the session. We will keep discussions strategic and technical today. We won't be discussing commercials. Of course, further discussion regarding commercials is welcome with your Bytes security account managers, but what today's session is really intended to educate and get you thinking about ways to reduce attack surfaces rather than being a commercial and monetary discussion. Lastly, we have a survey at the end. Please do fill it in so myself and our presenters can make sure these sessions continue to hit the mark, and there will be a recording available after the session so that you can share that insight with your wider teams. So a little bit about Bytes. We are an independent security reseller within the Bytes group. We are dedicated to networking and security. We've been specialising in that area since 1999, so that's over 16 years. Since that time, we've seen continuous yearly growth of over 20% by specialising and focusing solely on security. A massive part of that is our passion for security education and ensuring customers can future-proof their estate against security threats. And it's really why we run sessions like today. We do enjoy top partner statuses with leading vendors such as Skybox, such as Checkpoint, and such as WebSense. And this ensures that we can deliver technical knowledge behind those solutions as well as commercial value to our customers. Lastly, it's worth noting that 50% of our employees are technical, which means that we deliver a full service portfolio, consultancy and direct-to-engineer support around solutions that we do provide. So that's enough about us. Let's talk about why we are here today. So why is the attack surface visibility needed? Why do people need to be looking at this area? There's just an ever-increasing flux of breaches. There's been more than 6 major data headlines in the last month in the UK, not to mention last week's major hack of over 5 million accounts, including children's data from VTech. And so the bad guys are getting in, essentially, and we want to equip you to know when they're getting in and also to block them and stop them getting out with data. At the same time, there's more complex security estates. People are accessing data differently, working from home, working from different places, and security operations teams are faced with vast screeds of raw data and information that they have to analyse to make decisions. So we see a real need to reduce that complexity. Coupled to that is there's multiple solutions that people have in place, IPS, different point solutions in addition to firewalls and content security and APT, and these don't talk to each other very well, so that just makes the security ops team's job harder. And that's essentially our last point. Security operations teams are being tasked to do more and more and more with essentially less resource. So we need some form of intelligent automation, to connect the dots essentially between these expert systems and avoid giving hackers time to play undisturbed on your networks. And that's why we're here today. So just lastly falls to me to introduce our guest speaker for today, Michelle Johnson-Cobb, who is the Vice President of Worldwide Marketing. She's led product marketing at Skybox since 2009 and has been involved in a myriad of executive marketing roles and product roles in security companies such as McAfee, LogLogic, etc. So a great voice of what's happening in the industry and how our security vendors are responding. And also Alistair Williams, who is the Technical Director from EMEA at Skybox. We're absolutely delighted he's able to take us through a technical demonstration today. He's been at Symantec and he's had over 2 decades of experience in security engineering and architecting roles, technical roles, so a fantastic insight into technically how solutions work. So I'm going to hand over to Michelle now. What I'm going to do is I'm just going to change the presenter over to Michelle. You will briefly go to a holding screen and then you should be able to hear and see Michelle's slides. Thanks very much.
All right, thank you, Shauna. Well, the slide that I'm putting up is what I feel is one of the most important slides to come out of the Verizon Data Breach Investigations report from this year. And this caught my attention because I think in one visual, it really shows the challenge that security professionals have today and the fact that we're going to have to do something different in order to address security in the future. What you see in this is that the top line, that red line, is an indication from years of research through the Verizon Data Breach reports of the time that it takes attackers to compromise networks. And so they've fitted this line here that shows that 80% of attackers can compromise the networks that they target within days, whereas defenders suffer from really quite a different time issue. You know, they're not able to really defend the networks in that same period of time. And so when you look at the gap between these two lines, you realize that there really is a big challenge ahead for security professionals. There's essentially been no change in this gap between attackers and defenders in about 10 years. And that is even given an extensive spend. I know over the last a year, the estimate is roughly 250 billion pounds that are spent annually around the world on security solutions. And it's clear that companies need to do something different. You know, continuing to spend that amount of money on security solutions and not being able to bring the risk down is certainly a concern. So why is this? Why do we find that that we're unable to make a dent to reduce the chance of attack? Well, one of the reasons is that the attack surface for organizations has really grown exponentially. And that's due to a number of reasons, of course, and Shona mentioned some of them. One is certainly the sheer size of networks today. And if you look at a typical enterprise, they've had to add in, of course, additional systems as business services have gone online, as additional employees have been added, as mobile devices have become part of the corporate network. There's, of course, a change and shift in some of the security controls that are used to more granular access policies as we see the need for organizations to tie more controls to a particular user and a particular application. Of course, the advent of cloud and mobile devices complicates the issue more, sometimes with infrastructure that the IT security team doesn't really have direct ownership of, but still has to understand how to secure. And of course, determined attackers who see financial benefit, of course, for attacking those corporate resources. And finally, complex interactions from a lot of the tools that companies have put in place to try to address this problem. And that complexity itself, the interaction between different devices that they depend on, is hard to understand, and it's hard to get a sense for how this affects the attack surface of the organization. So is there a way to get a handle on this? Well, one of the best practices is certainly to make sure that you have as much visibility as possible. And that includes various layers of information that you need to understand, you need to be able to put together to have a better picture for what's going on in your environment and how to address it. So at the first level, that can include the information on what you're trying to protect. So assets such as servers, workstations, where is the data located, and really having an understanding of the value of those assets. Another layer of information is those security controls and all those different devices from different vendors, firewalls and intrusion prevention systems, and making sure to include the data from those systems in this picture. The network topology, of course, understanding routers and switches because they're part of that fabric and affect the access paths and risks that can be seen in a network. And outside forces such as vulnerabilities and new vulnerabilities that may be reported by a vendor and affect those host systems inside the network with vulnerabilities on key applications or key operating systems. And of course threats. Inside, outside, there are certainly determined attackers and malware that is looking for a way to get in. And so really you have to be able to put together all of these different layers to understand the security picture and have a better ability to deal with it. When you have that picture, you can do a number of things, and one of them I'd call a second best practice is being able to use that view of your attack surface to figure out where you may be attacked. And that's best done through something like attack simulation, where you can combine the information from those different layers. For example, understanding which vulnerabilities are present in the network, being able to correlate that with information such as the security controls that are in place. Are those vulnerabilities protected or essentially blocked due to a signature on an intrusion prevention system? Or is that vulnerability exploitable and can lead to an attack path that allows me to get to my customer data or my financial systems? So being able to use this layered picture of the attack surface and do something with it is very helpful to organizations. A third best practice is certainly to make sure that you're doing the right things to keep up with new information, particularly new vulnerabilities and threats. And I have here a couple of charts. The one on the upper left is also from the Verizon Data Breach Report and shows the ramp up of exploits as they're created for new vulnerabilities that are reported. And what you see that's interesting is that there's an initial, quite fast rise in the first 4 to 6 weeks after a new CVE is exploited. We see that 50–60% of new vulnerabilities have an exploit available typically in the first month or so. And what that means, of course, is organizations should act quickly. If you have a report of a vulnerability and you need to figure out very quickly, how can this affect my network? What should I do about it? Because the chance that that is going to have an exploit available are going to rise very quickly. And in fact, if it's a well-publicized vulnerability, we tend to see that increase happens even faster. Literally, the advertising of that vulnerability affects the desire of hackers to exploit it and exploit it quickly. On the right-hand side, though, you see that the problem is not just about what you do in the first few weeks, it's what you do over a long period of time. So we see that older vulnerabilities are continuously exploited. In fact, when we look over the last year at the top 10 most exploited vulnerabilities, we see a lot of numbers in here. 2002, 2012, there's vulnerabilities that are continuing to be exploited years after they're released. And so it's not just a matter of addressing the latest thing, but to continue to chip away at the vulnerability risk that you have in your organization. Another important point is to make sure that you're continuing to look for security gaps in firewalls and network devices, certainly that perimeter and that fabric of the network that affects things like risky paths between point A and point B. So to do this, you need to not only have that broad visibility of the attack surface that we talked about at the beginning, but also be able to drill down to detailed levels to get complete visibility of those firewalls, down to the rules, down to the routing, so that you really understand the interaction between different devices and can highlight things like risky access paths that would allow a port on a firewall to allow traffic from the internet to get to a key part of your systems, or other issues that could be presented by improper use of firewall rules, conflicts, platform configuration issues. So you need that detailed view as well as the big picture to be able to implement changes and reduce risk. And then finally, as we're talking about risks, you need to have a process in place to be able to handle planned changes on a consistent manner so that you can really monitor the entire process from an initial change request. Let's say a new business service is requested and that involves changes of firewalls, changes of access policies within the network, being able to understand and do a risk assessment that could indicate potential issues well before that change is made. And so it's very important for organizations that are dealing often with dozens of changes a day or more to be able to have a consistent process in place to be able to automate this process from change request through risk assessment and all the way down to getting the right information necessary to implement those changes effectively. So in summary, I've mentioned 5 key points. One, certainly an understanding of your attack surface and is necessary to get a handle on the security situation you face today and really achieve that holistic understanding of all of those security issues and how your network in particular is affected. Second, using attack simulation as a way to find risks that are exploitable in your network and help that attack simulation helps you do prioritization of risks as a triage step based on the challenges that that are present in your particular network. A third, staying on top of new threats, so again, using new information about vulnerabilities or threats and being able to tell quickly how you're impacted and keeping up with the deluge of new information is critical. Closing those network device gaps allows you to keep your system clean, keep it in policy and compliant, and help to reduce the chance of any kind of data breach or attack, and minimizing the risk of proposed changes allows you to make sure that you maintain that security posture throughout the addition of new services in your environment. And with that, we'll go to Alistair for a demonstration.
Great, thank you very much, Michelle. So hopefully you are all looking at the Skybox Vulnerability Control administrative console. So really for the purpose of the next 30 minutes, I'd like to walk through a number of aspects of the Skybox solution, covering a number of the things that Michelle's been speaking about this morning. So I guess before we get into the demonstration itself, it's probably worth just covering what Skybox is. Skybox fundamentally is a modeling and simulation technology. That is, we create a virtual representation of an organizational network within the Skybox data model. And with that data model, we can then apply a variety of different types of analytics and analysis in order to address a variety of different use cases and scenarios. Now, from a deployment perspective, Skybox is available in 3 different deployment options. So firstly, we have a Skybox appliance. So that is a Skybox branded piece of tin that has a hardened underlying operating system, all of our application software and third-party dependencies. So it's ready to go out of the box. The second option is a virtual appliance. So that is the same software payload that sits on our physical appliance, but this time it runs under virtualization platforms like VMware ESX or ESXi. And then last but not least, we have a traditional software installer. That is, our customers can elect to provide their own hardware platform onto which they will install an operating system of their preference, whether it be Windows, Linux, Red Hat, CentOS, etc., and then install our application software on top of that. From an architectural point of view, there are 3 main components of the architecture. The first is what we refer to as the Skybox server. Now, the Skybox server is the main modeling engine. It's where all of the data that is of interest to Skybox is going to be normalized. It's where we create that data model, and it's where we perform the analysis. The second component is the collector. Now, the purpose of the collector is to facilitate the gathering of the data that we want to ingest into the Skybox server. So the collector is responsible for communicating with those data sources using the available APIs and administrative protocols that the various technologies and solutions that we're looking to integrate with provide. The third component is the manager. That's the administrative console, which is what you're looking at the screen now. Now, once the platform itself is deployed, in order to build that model, we need to first start ingesting data from a number of different data sources. Now, as Michelle showed in one of her slides, the first stage is really to build up visibility of the network infrastructure. So we want to have visibility of the security controls, so the firewalls, the intrusion prevention devices, but also the other layer 3 infrastructure devices, the devices that connect the dots, if you like, so the routers and the load balancers. Now, within Skybox, we do that within the operational console. The operational console is the place where we configure a series of tasks that are going to describe to Skybox what information we want to import and the information with which to import that data. So we've just taken an example here. It's a checkpoint firewall. Skybox is going to use the OPSEC API, CPMI. We're going to populate the task with the IP address and the credentials of the management platform, and then Skybox will launch this task and retrieve the configurations of the managed modules. Now, as you saw from the list here, there are many different devices that we support. I think somewhere in the region of about 95 to 100 different device vendors and technologies are currently supported by Skybox currently. Now, once the task has executed and it has retrieved the vendor-specific representation of that device's configuration. So just take a couple of examples there. If, for example, we were pulling a configuration from a Cisco firewall, what Skybox is doing is basically running a show conf and a show IP route command in order to grab the raw configuration. On something like a Palo Alto, we're running a number of API calls, REST API calls, to retrieve a config.xml file. So that data that we're bringing back is the vendor-specific representation. So the first thing that the Skybox collector does with that after retrieving it is to normalize that data. So we want to build up a consistent picture about that device. So how is it physically and logically attached to the network? What network interfaces does this device have? So we can see here a list of interfaces that we've extracted from that device's configuration. But also, which network segments is this device directly attached to? Thirdly, we want to ingest the device's routing table. So we want to build up a picture of how this device routes traffic to non-directly attached networks, and that's going to incorporate both the static and the dynamic routing table. And then last but not least, we want to build up a picture of the access control rules. We want to understand what traffic can and cannot traverse this particular device, but also over here on the right-hand side, we can see the object tree. We want to understand how the rule itself is constructed from an object perspective. Now, this becomes particularly important when we start doing things like firewall optimization, understanding which rules and objects are being used and how frequently and when they were last used, with a view of optimizing and cleaning up the rule base. We're also going to do that for the routers, the load balancers, and generally any other part of the network infrastructure. Now, once we've got all of that data in and we've normalized that, one of the first outputs from Skybox is the visualization of the Skybox model. Now, that is presented to the users of Skybox in the network map, which is what you're looking at here. So we can see that Skybox has built an interactive map that we can interrogate things like interfaces on a device, the routing tables, etc., etc. And for many organizations, this is really the first time they've seen an accurate representation of what their network actually looks like, as opposed to what they thought it looked like, what they've been led to believe it looked like, or a number of other things. From here, we have the ability to export that to Visio. So, in a lot of organizations, Skybox is used to provide updated network architecture documentation in an automated fashion. So, certainly with some of our clients, they've had, teams of people producing Visio documents on a day-to-day basis. Those teams have been repurposed to providing something that is of much more benefit to the organization from a business perspective, as opposed to just producing network diagrams. Now, once we visualize the model, we can then begin to interrogate that. So one of the capabilities that we provide within Skybox we refer to as Access Analyzer. Now, Access Analyzer allows us to ask questions of the model. So think Access Analyzer as almost Google Maps for your network. So what I'm doing here is I'm going to specify a source, and I'm going to ask the model to tell me from that source, which is the internet ingress egress point, what access is there into my organization. Skybox is querying the model, and it's returning a list of the areas of the network which are accessible. We can see that includes Europe, for example, and we can drill down into that and see specifically within Europe which country is reachable, Paris, and within Paris which specific network segments are reachable, but also over which ports and protocols. By clicking on that, Skybox then provides a visual representation of the path. We can see the source over here, we can see the network path that it's traversing across the infrastructure, and we can see there over on the right-hand side the destination network which is reachable for the particular port or application that I've drilled down into. Now, in this central panel here, what we're looking at is the detailed path analysis. How is that connectivity actually being provided beyond just a list of participating devices? Well, over on the right-hand side, we can see in the table there the routing rules. The routing rule on each of those devices that is being used in order to forward the packet to the next hop in order to get to that remote destination network over there in Paris. But also, as an example, the ACL on each of these devices that is allowing the connectivity. So by clicking on that, we can see Skybox has dropped down into the normalized representation of the rule base. We can see that here, it's rule number 8. And then over here on the right-hand side, Skybox has highlighted the specific objects within that rule that's facilitating the connectivity that I've drilled down into. Now, I'm just very quickly going to give one other example. Let's imagine that we wanted to allow connectivity from the internet to a particular workstation in Paris, for example. Let's imagine that we wanted to allow that connectivity over a particular TCP protocol. So I'm just going to specify that here, 1234 TCP, and say again, click Analyze. Now, Skybox is going to interrogate the model again, and very quickly it's come back and it's told me that currently there is no access between the source and destination that I'd stipulated for the service that I've specified. Now, if I wanted to understand why that connectivity is not being allowed, I can toggle there to block destinations. I can drill down to the target IP address that I'm trying to get access to from the internet for the particular protocol that I'd specified. And Skybox will provide, firstly, a visual representation of that. So what we're seeing there is that there is an end-to-end path from a network connectivity perspective. However, both the main firewall and the development firewall are currently configured to block that access. And that's reinforced here by the detailed path analysis. So in the same way that this showed previously the rules that were allowing the access, it's now showing me the rules on those two firewalls that is denying the access. Now, if one firewall was allowing and one was blocking, we'd see that quite clearly here. If the different devices didn't have the relevant routing rules present on them, we would see the words broken route against the device that didn't know how and where to forward the packet to. And similarly, if there was any network address translation that was occurring, we would see the word translate in a turquoise color, beneath which would be would specify the specific translation that was occurring, whether it be source, destination, and/or service translation. So this is really what we mean by modeling and simulation. You know, our ability to create a computer model that mimics the behavior of the organizational network, which we can then query from an end-to-end perspective to understand where connectivity does and does not exist, and over which protocols and services and applications. And it's this modeling and simulation that underpins all of the 5 different product modules that we have. I know Michelle didn't go into it in great detail, but you know, Skybox is a platform that's made up of 5 product modules, one being file assurance, one being change management, one being network assurance, another being vulnerability control, and the last but not least is threat manager. And all of those different product modules address different use cases within an organization. And it's quite normal for our customers to invest in one or two of those initially, and then over a period of time look to adopt additional modules to take advantage of the extended capabilities. But all of the modules leverage this underlying modeling and simulation capability. So really from an attack surface perspective, which is really what we're here to talk about today, there are some additional data feeds that we need to bring into the Skybox model. Really what we've covered so far is how we get the data into Skybox from a network infrastructure perspective, the normalization of that data such that we can populate the Skybox data model, and then how we present that and can interrogate that from an access simulation perspective. To understand the attack surface, there are three additional elements that we look to bring into the data model. The first of those is the vulnerability data. So in order to understand the attack surface, we not only want to understand the infrastructure and the security controls, we want to understand what devices exist within the network, the endpoints, and what weaknesses and vulnerabilities those devices have. And there's really two main sources of information that we can use for that. The first is by ingesting traditional vulnerability scan data. So in the same way that we ingest firewall, router, load balancer configurations, we have a series of tasks that allow us to bring in data from somewhere in the region of about 12 to 15 different network vulnerability scans. So things like Qualys, Nessus, Rapid7, Outpost 24, etc., etc. And we're simply going to specify the source of that information, any credentials that we need in order to retrieve the scan results. It's a read-only account, as with all of the data collection methods. And really what that's going to result in is a normalized representation of vulnerability occurrences. So what we're seeing here is a high severity vulnerability that we've ingested from a data source. We can see the corresponding CVSS score associated with that vulnerability. We can see the specific asset on which that vulnerability has been detected, and we can see the specific service or port on which that vulnerable application is listening. Now there's also a variety of other metadata that we provide as part of our solution. So we provide what we call the vulnerability dictionary. It's some content that is maintained on a day-to-day basis. It's published. Our customers download that into the product solution. It's an automated feed, and that allows us to correlate across these different sources. It allows us to provide information around the vulnerabilities themselves, where to go look for more detailed information, solutions, etc., the affected platforms. But also importantly, one of the things that we do is we actually correlate the specific solutions with the specific vulnerabilities. So we know, for example, that this specific vulnerability that I'd selected can actually be mitigated in a variety of different ways: patching, upgrades, specific IPS signatures on things like Palo Alto, Tipping Point, SourceFire, etc., etc. So the vulnerability dictionary is allows us to do all of that cross-correlation between these different information sources, such that we can go on to do the attack simulation in a few moments. So that was an example of where we are being explicitly told about the vulnerability occurrences. The other method that we can use to understand vulnerabilities is using our scanless vulnerability detection capability. Now this is something that we launched about 12-18 months ago now, and it's a method that we can use to ingest data typically from patch management systems like Microsoft SCCM. Now SCCM is a really rich repository of information that describes enough about an endpoint that we can actually derive or deduce the vulnerabilities for ourselves. So just as an example, SCCM is going to tell us the host name, the IP address. It's going to tell us the operating system that's running. It's going to tell us the service pack level. It's going to give us information on the installed patches, the missing patches, but also the installed third-party products and their versions. Now with that information, we can do a lookup in that same Skybox vulnerability dictionary to actually derive or deduce the vulnerabilities. So in simple terms, if we know a machine is running Adobe Acrobat Reader 10.2, we can look that up in the Skybox dictionary and know explicitly what vulnerabilities exist in that version of Adobe Acrobat Reader. And then what the task does is to create a representation of that endpoint in the Skybox model and attaches to it all of the vulnerabilities that we've derived or deduced from the patch and version information. So that's how we get visibility about the endpoints. The second main feed is the threat origins or threat actors. Now, the threat origins are the places on your network infrastructure that you believe you're at risk of an attack from. So here's just an example. It's an internet hacker. If you think back to that network map that we had, a few minutes ago, it's located on that ingress-egress cloud that's defined as being the internet. And then we categorize them and we define the characteristics of that threat actor in terms of their skill, likelihood of attack, and a number of other characteristics as well. And we can have as many or as few threat actors as you like. You might define threat actors that represent your internet, internet connection, perhaps your employees coming in over an SSL VPN. You might put a threat actor on the end of a site-to-site VPN to a third-party business partner. You might put a threat actor on the DMZ to simulate a zero-day type scenario, or you might place a threat actor on one or more of your internal networks to sort of take into account things like corrupted insiders, or perhaps somebody breaking into a building and plugging in an Ethernet, a laptop into an Ethernet port that's accessible. And the third and final piece is the business asset context. When Skybox sort of analyzes the data and provides that attack surface visibility, really what we're doing is trying to understand what, if any, of your business assets are at risk. Now, in order to be able to answer that question, we need to know what are the business assets. So the business assets are basically either defined in Skybox directly, or we can ingest that data from third-party CMDBs that have the description of the business assets, the business asset name, the systems that make up that business asset, but also what are the business impacts. So we want to understand what is the impact to your organization if one or more systems within this business asset is compromised. So is there a loss of confidentiality? Is there a loss of integrity? Or is there a loss of availability of the data that resides within those systems? But also, what is the damage level, low, medium, high, etc.? And that can either be a value such as the one that you see here, or monetary as well. So that's the business asset context. So what we've got now is visibility of the network infrastructure. We understand the network topology. We understand the access that exists between any 2 points within that network that we've modeled, and we walk through that. We've then layered on top of that the vulnerability data. So we now know what endpoints exist and the vulnerabilities and weaknesses that those endpoints have. We know where your points of threat origin of concern are, and then we've also got a visibility and understanding of the critical business systems, platforms and services that you're providing either internally or externally to customers. What Skybox then does is then do its sort of analysis. So we've ingested all of that data, and there's a number of views of data. So the first thing is to use the different centers that we provide to ensure that the data that we're ingesting is of good quality. Good quality data that is recent, up-to-date and fresh is going to give good output. Scan data or patch data or any other data that is inherently old, it's from last week, last month, etc., means that the analysis that we do will also be based upon old, stale data. And obviously that's not a desirable situation. We then start to actually do the analysis itself. So, Skybox will provide a series of heat maps. We can see from a vulnerability metrics point of view where we've got areas that are of most concern. And one of the great things that Skybox does is we actually understand the cumulative effect of vendor patches and solutions. So within Skybox, within that vulnerability dictionary, we've actually mapped all of those vendor patches to the specific vulnerabilities that they resolve. So if you think about it, what Skybox has on one hand is visibility of all of the vulnerabilities within your estate, whether we've learned that from traditional network vulnerability scanners or whether we've learned that using our scanless vulnerability detection capability from the patch source. In the other hand, our vulnerability dictionary describes those vendor solutions and the issues that it fixes. So what Skybox does is it marries the two together. It kind of, figures out for itself what are the fewest patches that you might look to deploy in your organization and where that will have the biggest benefit in vulnerability level reduction. Okay, so we would understand that, MS Security Bulletin 2015-0032 solves CVE 1, 2, 3, 4, 5, 6, and 7, but also 101, 105, and 107, for example. And Skybox says, oh, okay, well, you've got 7 of those issues, therefore applying this patch will bring down the level of vulnerabilities by X%. So it's really there to aid the vulnerability and patch management processes within your organization by providing objective, quantifiable data that gives you visibility on the things you need to do, where you need to do them, but also a tangible benefit in terms of a metric that you will achieve by doing one or more things. On the other hand, we look at the exposure of those vulnerabilities. So, a simple example there might be, you've got a vulnerability on a machine in the DMZ in the web server that's running on that DMZ server. But if that web server isn't accessible from the internet, for example, over the ports and services required to exploit that vulnerability, then whilst that vulnerability may be present, it doesn't actually present a risk to the organization because it's not exploitable or reachable, it's inaccessible. And this is where the attack simulation comes in. The attack simulation is almost like a virtual penetration test. So from each of those threat origins, we are starting a penetration test, but it's in the model. It's not on your real network. It's within the model that is built using all of those different data sources. And the output of that is, firstly, a risk score against each of those business assets. So you can understand, sort of from a compare and contrast perspective, which have most attention from a remediation perspective. But then you can drill down into what we refer to as the Attack Explorer. Now, the Attack Explorer provides visibility of the attack vectors themselves. So what I've done here is I've drilled down into a particular business asset, which was the back-end finance application servers. And then I went into the highlight view. Now, the highlight view shows us the single most likely highest risk attack path. Now, this happens to be an attack path from our internet threat actor. Okay. Now, Skybox knows that the internet threat actor has a viable access path into the DMZ. Now, we've calculated that because we have the configurations of the network infrastructure components. So Skybox knows that from the internet source, there is an access path across the main firewall on rule 2, across the production firewall on rule 2, thereby giving access to this machine in the DMZ on port 80. We know that because we've got the routing tables, the firewall ACLs, etc., etc. Well, that machine that we now know is accessible, Skybox has some vulnerability scan data for. Okay, we happen to have got it from Qualys. It could have been any one of the other vulnerability scanners that we support. Now, in this example, Qualys had explicitly told us that it had found a machine that had an IP address of 33.11. That machine was listening on port 80, and that it had this vulnerability in Microsoft IIS. Now, within our Skybox vulnerability dictionary, we also contain the attack metadata, the pre-attack and post-attack condition information. Now, what this is telling me is that the exploit of that vulnerability gives root level control of that machine. And on getting root level control of that machine, the attacker is able to initiate an onward step. That is, they can now be seen by the network as originating from the IP address of the exploited machine itself in the DMZ. And because they are now being seen by the network as originating from the DMZ machine itself, they are able to traverse a number of different firewalls using different firewall rules, and thereby getting access to a machine that is much deeper within the organization. and we can see that that's the finance server here, and the access is also over port 80. Now this time if I click on the finance machine itself, we didn't actually have vulnerability scan data. So Qualys, for whatever reason, hadn't scanned this machine. Maybe there wasn't enough licenses. We couldn't afford those. Skybox has actually leveraged a patch source in this example. So Skybox has used the SCCM integration along with the vulnerability detector capability to build a picture of the fact that this machine is running IBM WebSphere 5.3. Now what Skybox has done is looked that particular version of WebSphere up in the dictionary and has derived or deduced that it has this particular CVE, 2012-5955. Now again, the achievement or the post-attack condition on the exploit of that vulnerability is such that we also have root level access. Now because that machine is a member of the back-end finance server application group, we've been able to compromise the confidentiality, the integrity, and the availability of the data that resides on that critical business application or platform. So this is really what we mean by attack simulation. It's understanding the chaining effect of vulnerability exploits across the organization from one or more threat actors using the available network topology and access given the security controls and configuration in order to get access to critical systems that you care about and would impact your business. Now there's lots of other sort of use cases, so we might look to export this type of information to a SIM. So the fact that we can understand where the risks are, we can communicate that to the SIM in the form of a watch list such that the SIM can actually build a set of correlation rules to watch for suspicious activity against those sort of points of compromise that you're aware of. Skybox can also make recommendations. I haven't got time to show you it this morning, but happy to organize follow-up sessions around perhaps which intrusion prevention signature would mitigate these particular exploits. So it's really about kind of opening up opportunities for mitigation. It's not always about patching. In this example, maybe we don't need port 80 access from the DMZ to the critical server. So in blocking that access on that second arrow there, we might actually mitigate the risk. Yes, we still have vulnerabilities that ultimately we need to address at some point in time, but the immediate risks and the business impacts have been taken care of in the short term. So at that point, I'm going to hand back to Shona now, as I believe there's a couple of questions that have come up, but I'll hand back to Shona.
Thank you very much for your presentation, Alistair. At this point, we are going to be running an interactive Q&A. So I'd like to invite anyone in the audience to ask any questions regarding either Michelle's or Alistair's presentations today. We'll answer those and then I'll wrap up and thank everyone for their time, really. So I'll just give a couple of minutes for people to open up the questions box and type in any appropriate questions they may have on any of the use cases or the technologies, or indeed some of the best practices that Michelle mentioned earlier. Okay, I do have one question come through at the moment. So we have a question regarding network traffic for you, Alistair. Does Skybox send traffic over the network to simulate the attacks? How does that work?
No, so Skybox is entirely offline. So the only traffic across the network is the retrieving of the device configurations and the retrieving of information from other data sources such as the patch repository, the vulnerability scanners. Those are all read-only connections, and that's the ingesting of the data. All of the analysis and analytics, the attack simulation, the virtual penetration testing, in the other modules that I didn't show today, things like the compliance checks, etc., is all done on the model. It's a sandbox, if you like, where this simulation analysis can be done. So we're not actually playing out any of these attacks or exploits on the live network. So there is no risk from that perspective. So it really provides an opportunity for understanding, where those attack paths exist, playing out different sort of remediation scenarios. So we have a what-if model You can switch to that up at the top. So sort of 3 different workspaces: live, what if, and forensics. So you can switch to what if, introduce sort of the countermeasures that you would perhaps consider deploying in the production environment, understand the effects of those, make sure that they are mitigating the attack and the attack vector as you would anticipate prior to deploying them in the live environment. The Skybox is entirely self-contained. It is a model-based analysis within the platform.
Okay, thank you. So I do have one more question. You mentioned IPS signatures. How does that figure into the attack surface?
Yes, that's a good question. I know I briefly mentioned it, but didn't really get a chance to go into it. So, an IPS is really like a firewall in a funny kind of way. So, an IPS has a set of rules, or more commonly known as a policy, and that policy describes, if you like, the signatures that are available for mitigating particular exploits. And those signatures can either be deactivated, i.e. doing nothing. Those signatures can be activated and detecting, so providing alerting around issues that are observed, or certain traffic and patterns that match the behavior of the signature definition. Or those signatures can be active and blocking, so they will prevent any exploits taking place that mimic the signature. So Skybox ingests that as well. So in the same way that we ingest a configuration from a firewall, we can ingest a configuration of an IPS, maybe tipping point, for example, and from that configuration we can understand where that IPS is placed in the infrastructure, so where it's sat, what traffic must go through it and what traffic can go around it, if you like. But we also understand the policy, so we understand what's turned off, what's detecting, and what's blocking. And that's actually considered in that attack path analysis. So, had the relevant signature be activated out there in the DMZ, that attack path wouldn't have been presented by Skybox, because Skybox would have known that the right signatures were activated in the right places, and therefore, whilst there may be vulnerabilities, there's currently a compensating control in the form of an IPS signature. Now, Skybox will actually make specific recommendations. In the Attack Explorer, you can actually right-click on a vulnerability and say, well, which signature would I need to turn on? And we'll give you the signature ID. And if you turn that on and then re-ingested the data, rerun the analysis, you'd be able to understand the impact of the change that you've made in terms of the activation of the signature. So, within our vulnerability dictionary, for all of the different IPSs that we support, we map all of the signature IDs with the corresponding CVEs and vulnerabilities that they mitigate, so that we can do that correlation, so that we can factor that into the attack surface simulation to give visibility of where you've got those compensating controls in place, or where you might look to turn them on in order to prevent current risks that exist.
Okay, thank you. So I have another question from the audience. You mentioned, Alistair, that Skybox is collecting information about network devices by running, for example, show commands, which the questioner knows is a light command. What about heavier commands such as debug? Is debug used as well? And if so, is it safer to let Skybox scan the network out of hours?
No, so they're just light commands. They're all read-only, show comp, show IP root VRF. These types of lightweight commands. Because all we need is essentially the information about the device's configuration, interfaces, routing, directly attached subnets. Dynamic routing table is important so that we can model that fully, and also the ACLs, NAT, and VPN. So we don't need any kind of debug commands. We don't need anything above and beyond read-only. Most customers choose to ingest the data once per day, and typically they do that in the early hours of the morning after their change window has ended, so that any sort of firewall changes that have been introduced at the end of the day are re-imported into the model before the subsequent analysis occurs. Some customers ingest the data multiple times a day. It's entirely up to the customers to the frequency of that, based upon their specific requirements.
That's great, thanks. And also for the gentleman who asked that question, in terms of the options sort of that would work for your specific business, then I'll make sure that your account manager can be aware of your question and has the opportunity to follow that up, on an individual basis.
And I think the other thing I would expand on that as well, Skybox isn't scanning the network. It's not like a vulnerability scanner where it's doing kind of a whole bunch of stuff that you're not necessarily fully aware of what it's doing. And what scanners will do will change based upon the signatures that are provided by those different vendors. You know, Skybox is, you know, performing a very specific function in terms of collecting from a relatively small number of data sources, so, you know, firewalls, routers, load balancers, etc. And for each of those device types, we can very specifically tell you the precise commands that we are using, and you'll, you know, we can provide that as a follow-up. You'll see, you know, clearly that there's nothing there that would be problematic to the network on an ongoing basis.
Thanks, Alistair. I'll just wrap up with one last question because I'm aware that we're running quite close to 11 o'clock. One question on assets. How does Skybox determine the importance of the assets?
So it's a really good question. You know, I think this is probably the area where most organizations struggle. You know, I think very few customers have undertaken kind of a comprehensive business asset classification exercise. You know, organizations that are subject to perhaps one or more regulatory requirements may have sort of classified a subset or portion of their infrastructure. So where things like PCI DSS or SOX or these other regulations come in play, you know, it's quite typical for us to see kind of a relatively small Excel spreadsheet that just kind of lists, you know, tens, maybe a few hundred servers. But, you know, all the time, you know, the back of that, there's always, you know, hundreds, if not thousands of more servers that sort of fall outside of that. So, you know, I guess there's a few approaches. So, you know, if a customer has done that, we could ingest that using a data connector from that existing source. If not, we can define that directly in Skybox. We'll take whatever information is available and then we'll kind of add to it. So within Skybox, we can do dynamic business assets based upon things like naming conventions or particular products or applications that are running, or maybe particular ports or services that are listening on the network. So, yeah, there's a variety of approaches that we tend to take, and usually it's a combination of these to sort of, you know, build out the picture. You know, Skybox is really about aggregating many different data sources that typically wouldn't be brought together. And it's that aggregation of data and being able to sort of cross-correlate between those different data sources that builds up the picture. So it isn't, you know, it's really only once you start getting the data in that you spot where the gaps are that you would then look to, you know, complete using, you know, a variety of different methods.
Thank you, and thank you also to everyone who has joined us this morning. I think that wraps up our question and answer session. If you have any further questions, however, regarding commercials, Skybox or the topic, please do forward those to your account manager, and as I said, we will also provide a recording of the session at the end. Lastly, it just remains for me to thank both Michelle and Alistair for their time this morning, as well as yourselves for your time and taking time out of your busy schedules to attend, and I trust that you found the information this morning useful. Thank you everyone, and good morning.